All right, today we're going to pull back the curtain on our digital world and look at two ideas that are honestly incredibly simple, but they're also super powerful. They're called stacks and queues, and they're running in the background of pretty much everything you do on a computer. It might sound a little technical, but I promise the core ideas are things you already get. Let's jump in.
So let me ask you this. You're working on something, you make a typo, and you hit undo, and bam, just like magic, your last action is gone. But have you ever stopped to think about how that actually works? How does your computer know what your last action was, and how does it keep track of everything in reverse?
Well, the answer isn't some crazy, complicated algorithm. It's actually based on a very simple rule about how to organize things. Really, it's about how data gets in line. And today, we're going to break down the two main ways our technology does this.
Okay, so let's tackle our first concept, which happens to be the secret behind that magic undo button. It's called a stack. And yeah, as the title here says, it's all about reversing time. The easiest way to get your head around a stack is to just picture a stack of plates at a cafeteria. When a clean plate comes out, where does it go? On top. And when you need a plate, you take one from, you guessed it, the top. You'd never try to yank one out from the middle, right? That would be a disaster. Well, that's it. That's the entire concept right there.
And this simple rule, well, it's got a name, LIFO. It stands for last in, first out. The very last plate you put on that stack is the very first one that's going to be taken off. This whole idea of reversing the order of things, that's the stack's superpower. Now, of course, in the computer world, we have our own lingo for this stuff. When you add a new item or a new plate to the top of the stack, we call that a push operation. You're literally pushing a new item onto the stack.
And when you remove that top item, we call that a pop operation. You just pop the most recent thing right off the top. So you push things on and you pop them off. And it all happens in the exact same place, the top. Simple as that.
Now, you might see this on the slide and think, whoa, what is O of 1? Don't worry, it represents a really simple and honestly beautiful idea, constant time. All it means is that pushing or popping an item takes the same tiny amount of time, whether your stack has 10 items or 10 million. It's always incredibly, incredibly fast.
So where do we actually see this LIFO thing in action? Well, that undo function is the perfect example. Every action you take gets pushed onto a stack. When you hit undo, the last action is popped off. Your web browser's back button, that's a stack too. It pops the last page you visited off a stack of your history. It's really the perfect tool for any time you need to backtrack or reverse your steps. All right, that's the stack. Now let's kind of flip the script and look at its counterpart. If stacks are all about reversing order and going backwards, our second concept, the queue, is all about preserving order. And the analogy here is something we all know well, a checkout line at a store. The first person to get in line is the first person who gets to the cashier. The line maintains a sense of fairness, of order. You can't just jump to the front, right? And this gives us our second big principle, FIFO, first in, first out. Totally different from the stack's LIFO. A queue processes things in the exact same order they showed up. It's all about preserving that original sequence. Just like with stacks, queues have their own special names for things. When a new person joins the checkout line, they go to the back. In the tech world, this is called an enqueue operation. You're adding an item to the very end of the queue. And when it's time to process the next person, where do we take them from? The front of the line, of course. This is called a dequeue operation. So notice the difference. We enqueue at the back, and we dequeue from the front. We're working with two different ends of the line. And trust me, queues are absolutely everywhere in technology. When you send a bunch of documents to a printer, they get put in a queue so they print in the order you sent them. When you send a text, it goes into a queue to make sure it gets delivered after the one you sent before it. Queues are just essential for any system that needs to be fair and process things in their original order. So we've got these two simple rules. Last in, first out for stacks, and first in, first out for queues. They really are opposites. And the crucial skill for any programmer or system designer is knowing which tool is the right one for the job. Let's just put them side by side. A stack is all about reversal. It cares most about the thing that just happened. A queue, on the other hand, is for preservation. It cares most about the thing that's been waiting the longest. One is about immediacy, and the other is all about fairness. And this table here just lays it all out perfectly. You've got the rule, LIFO versus FIFO. The real-world analogy to help you remember, a stack of plates versus a waiting line. And the core reason you'd use them? Stacks are for reversing and backtracking, while queues are for maintaining order and guaranteeing fairness.
So, when do you actually use a stack? Well, think about any time you need to go backwards. Seriously. Whether you're trying to reverse the sequence of letters, backtrack out of a maze in a video game, or deal with nested information. Kind of like those Russian dolls. A stack is your go-to tool. And a queue? You'll want that whenever order and fairness are absolutely non-negotiable. It's perfect for any system that has to manage a shared resource, like a printer or a web server, making sure that the first request that came in is the first one that gets handled. No cutting in line. So why does any of this really matter? Because these two super simple ideas, these two little constraints on how we access data, they form the foundation for a huge amount of the complex stuff going on in our digital world.
I love how our source material puts it. Stacks and queues are more than just programming tools. They are fundamental ideas. By imposing a really simple rule, like you can only touch the top plate, we can create systems that manage everything from your browser history to the very way our computer programs run. It's a pretty beautiful example of how simple rules can create powerful, elegant solutions.
And that leaves us with a pretty fascinating question to think about. If just reversing and preserving order can build so much of our digital world, what other simple, fundamental rules are hiding in plain sight, quietly making everything we do possible? Thanks for watching.